P300 BCI brain computer interface and its applications. If you can see the interesting picture where you find on y-axis certain voltage, we know that all brain signals are always in some milli or microvolts, rather microvolts. And you can clearly see that on x-axis, there is latency in millisecond. We have already discussed about latency, peak negative, peak positive in our previous lectures. So you can see here N1. I hope you understand the meaning of N1. This N1 is the first negative, a significant negative after 100 millisecond. 1 for 100, you know it very well. And the next peak is coming here, and that is after 200 millisecond. So this is your P200, P200, P2, it is also denoted by P2, P200, but there is significant amount of, potential. There is a large amount of potential in comparison with this, that is P3, which is P300, and it comes or it is positive peak after 300 millisecond. So total latency time, you hope you understand the latency. There is another picture which is given here. This is, we will discuss in detail about all these applications. So there are different, mechanisms by which a person watches certain letter, observes certain letter, certain picture, certain sound, a person hears, and then the person's reaction will generate the signal. Because you watch a picture, surprisingly, you hear a sound surprisingly, or you see something very suddenly, then definitely you will be reacting to that sound, that picture, or that letter. So that reaction, moment you saw the stimuli, this stimuli, you can say in this example, the letter. Suppose a person who is sitting here is seeing these letters, and just after seeing these letters, this particular potential is generated. So this is the time called as latency time. From the beginning, the letters were seen by the candidate, the human, and then after 300 millisecond, her reaction or response was recorded as P3. So this is a very, very popular, very, very popular BCI type of BCI brain computer interface, and it is used in number of controlling applications. So this particular lecture highlights about P300 BCI and its applications. So we will discuss some, the fundamental principles, overview, what are the different types of P300 paradigms, and how those paradigms are used in order to make the BCI understand that what does brain signal indicate, what does brain signal infer. So let's begin with BCI. As you know that human brain is the most complex because we are talking about P300 BCI. So obviously in the very first slide, we have to again recapitulate or recall about what do we mean by BCI. So human brain, we know that is a very, very complex organ. It has billions of neurons, and all those neurons are there in the nervous system, and brain is always at the center of human nervous system. 100 billion nerve cells are interconnected to build the functionality of the human brain. How the human brain functions, there are a number of functionalities associated in different parts of the brain and interconnecting these 100 billions of neurons. So the complexity, is so much. Complexity is very high. And in order to make it very simple, in order to simplify the complexity is a difficult task. So the brain carries out executive functions such as making decisions, making reasons, processing thoughts, and planning for the next task. In the neuroscience and neuroengineering, generally electrophysiological techniques we use for studying the electrical properties of the neurons. Rather, electrical activities of neurons are measured in terms of electrical properties, which are electrophysiological properties. One of the popular example is EEG. So to study human brain, what do? There are many methods. We can just capture the signal when a person is engaged in some activities, or we can we can stimulate some signal to the human brain, and the reaction to that stimuli can be recorded as a signal. So stimulate, the brain can be stimulated it by presenting a paradigm. So what is paradigm here? I was telling you there are different types of systems by which we can stimulate, we can provide some sudden or surprising signal to the human brain, either in the form of letter, picture, sound, and so on. So that is called as paradigm. So this is one example where you can understand the BCI as well as how does P300 work. So look at here that, this is a pattern. So what happens, the person who is looking at certain target patterns, the patterns may have certain characters, dots. So these are the patterns which are given on the screen monitor in front of the person. The person watches those patterns or letters or pictures, whatever, and then the stimuli, this stimuli, uh, you know, uh, uh, causes the brain signals or causes certain part of the brain to react, and that reaction is recorded, what we are generally using through biosignal processing we have discussed in previous lectures, and then we amplify DC and so on. We measure EEG signal, then EEG can be, analyzed, classification can be done, and the feedback can be given to this device. So in these BCI, what is very important is measuring or recording the response or the reaction of a person once the person is subjected to certain stimuli, and that reaction comes after 300 millisecond, which is why the and this is why we call it as P300 system. Again, this is another interesting diagram where you can understand P300 very simply, a simple manner and easily. Look at here that the person actually watches or sees certain stimulus, and that stimulus causes certain response coming from the brain, and it goes to signal processing circuit. So probably say if we have EEG signal, then it goes to signal processing. We can take statistics, we can take some coefficients, all these analysis we have already discussed. And finally, you can see that the signal which is actually present is, look at here that these are the different things like P1, P1, N1, P2, N2. In different manner, we get different peaks. But we are interested in peak 300. ERP is a yoked response, potential is an electrophysiological logical response triggered by stimulation and firing of neurons. And a specific physiological event or a sensor can be employed to generate the stimulation. The stimulation can also be generated by a number of arrangements. For example, visual auditory, we can create some visual impact in front of the eyes. We can produce certain sound, and that can give the stimulus to the ears. Some tactile, maybe, some person can be asked to touch something and experience the touch, the feeling the touch, and it will produce certain reaction in the brain, and that has to be recorded. For example, appearance of a character on a visual screen in front of a person, we can put a screen or a monitor there. We can produce certain characters, certain letters, and a certain tone presented over the earphone. These kind of thing can be given, and that stimulus produced either by visual impact, auditory, or tactile, it generates a detectable but time delayed electrical wave. I'm talking about what is P300. It is detectable, stimulus will be detected by the brain, but time delayed electrical wave. It doesn't react immediately. After certain time delay, in the form of EEG, it is recorded starting from time of presenting the stimulus to the time when EEG settles down. So that particular time is known as latency time. So the detection method can be any method like ensemble averaging or linear discriminant analysis or SVM, support vector machine, all these algorithms can be used to analyze and measure the ERP, that is that evoked response potential, or sometimes event related potential. That is better name, event related potential. Why the appropriate name is the event related potential? Because what is the event which is causing the stimulus to the brain? Whether it's a visual event, whether there is a sound being generated to create the stimulus, or whether there is some system which is through which the person is subjected to touch upon, like that. So this is the main waveform of P300. So the event related potential ERP is generated. The stimulus was given it, in the beginning, and the moment the person watches or sees or listens the stimulus, just after 300 millisecond, positive peak is generated, and this potential or this response potential is used in the analysis and rather to generate different control signals. So P300 is a type of visually evoked potential. Visually evoked potential. Visually means it is mainly related with our visual system. So the P300 ERP is embedded within the EEG signal. So in what form the signal is recorded? It is recorded in the form of EEG. It can be divided into exogenous and endogenous, that P300. When it is called as exogenous and when it is called as endogenous, early components are distributed over 150 milliseconds. Remember, see, the stimulus has already started in the beginning. The moment stimulus starts, the response will be observed. The reaction will start coming out. But the reaction will be, those components will be minor components till 150 millisecond. Look at here, till 100 moment when you get a P1 and N1. Till then, this is actually N2 in this case. This is P1 and this is N1. So till this 150 millisecond, the components are minor, and whereas longer latency, which is called as endogenous, longer latency, see the latency which is longer. So components elicit after another 150 milliseconds. So the total is 300. So the latency within the range is generally, you look at here, 250 to 750 millisecond. So it goes till 750 millisecond, which is started actually, it is started producing positive value right from 250. Look at here, this is 300 millisecond. So right from 250, actually it is started having certain positive value, goes till certain maximum positive value, then it still it is not very low. It still remains certain, remains to have certain value, and till 700 millisecond. But what is the best response in this BCI is P300. So generally P300 is demonstrated by decision making. How P300 is generated, how it is demonstrated. This is actually by decision making and learning that rare event has occurred. I was telling you, rare event means the activities which are very normal to us, the activities which are very normal to our visual system might not create sudden reaction. The person, or some image or some picture which we are looking at very suddenly, and that causes very sudden impact, you can rather say surprising impact, or that kind of event. If that occurs, some things appear to be learned if and only if they are surprising. So whenever surprising factor is there, astonishing factor is there, that causes sudden reaction called as this P300 peak. And this is the fundamental basis of P300 BCI. So the variable latency, you can see the variable latency here is associated with the difficulty of decision making. So actual decision making, it comes here, but there is always a confusion that the level of difficulty of decision making is starting from 250 millisecond. The responses are obtained over, what is important is parietal lobe, which is the area in the brain from where you get the response, it is actually parietal lobe from where the ERP is generated for P300, that is visually evoked potential. So this is another diagram where you can see there are three cases how the spatial amplitude distribution. How spatial amplitude distribution means how the different parts of your brain are impacted. And that is actually when you see in terms of wave, you will find it symmetric. Look at here, but at almost at certain value, it is going peak. That is this particular peak. And it is largest at the parietal electrode sites and is attenuated as recording to sites moved to central and frontal location. So a typical P300 response is a width of 150 to 200 millisecond and a triangular structure. The peak potential is 2 to 5 microvolt, which is less than brain's background activity. And single P300 is a low, SNR is actually low, signal to noise ratio, and that can be enhanced by averaging over multiple responses. So it's not single response, but you can take so many responses, and accumulation of those responses will give a stronger signal for the P300 to take certain decisions. So you see here, generating the ERP. How do we generate ERP? There are 2, 3 mechanisms which we are going to talk in detail in coming slides. Like you see here, T is a target, S is a standard, and ERP is generated. So response to the target. So what is this is very interesting for P300. Look at here, ERP 300. There are two things, single stimulus. One is response to target, another is standard. Remember, I was telling you, therefore it is calling as oddball. What is oddball means? Something which is odd. Something which is surprising to you will be your target, not the all the things which you are seeing. Everything you are seeing is not the target. Something which is creating some sudden impact. That is therefore it is called as oddball, right? And that will create something single stimulus in terms of this. And here in the probably oddball is this one, but okay, single stimulus. When you see the target, when you see the standard is also a target, but not unusual. In oddball, easy stimulus discrimination is there. There are a lot of standard targets are there, but suddenly you find a target which is very unusual. Like there are three stimulus where you find that difficult stimulus discrimination. When there are so many, then you have some difficulty. So there may be some distractor stimulus also. So we will talk about what is this P3A, P3B, but here it is very clear. In the first case, very clear is there. Second case also you see here. Now let me tell you why we are differentiating between S and T. This is very important. You look at for S, the top one is P300, but for, I'm sorry, for T, that is target. But for S, the lower one, where the amplitude is very less. So therefore, the target means what we are looking at, what we are actually viewing, what we are watching. So the target, which is very unusual, will create this impact actually 2 to 5 microvolt. And therefore, you see the response like this. But here, difficult stimulus discrimination here between the two, and then there is one more. So what happens that you may get responses like these two different peaks you may get, but they are not actually the correct target. So let us understand this. To generate P300 paradigms, I was telling you paradigm. What are the paradigm? Paradigm is a mechanism. Paradigm is something either a visual impact or auditory impact that helps in generating the ERP potential. This is a number of types. Single stimulus, look at here, a single stimulus here, then oddball, and the three stimulus paradigm. The subject is instructed to follow the occurrence of target. When you are asking a person, I want to record your ERP, P300 ERP, then you will request the subject to follow the occurrence of target by pressing a button or mentally counting. You have to ask him or her, just press a button and count something suddenly, either mentally or watch something. The single stimulus paradigm irregularly presents just one type of stimuli or target with zero occurrence of any other target. And oddball paradigm is presented to a subject. In this case, this paradigm will be presented to the subject. This thing will become even more clear when we'll see the examples of these three cases: single stimulus, oddball, and three stimulus. So what we'll see, a group of light emitting diodes or other medium to generate a sequence of events that can be categorized into two classes. We'll say that watch all these LEDs and try to classify in two categories. Like that, what impact it will create. Frequently presented, non-target, irrelevant. Non-target, irrelevant, and rarely presented target stimuli have to be differentiated. So this is very interesting what I was trying to tell you, 3A and 3. So let us understand what these 3A and 3B are. So you look at this. In oddball, two events are presented to different probabilities. Two events, look at here. These are the two events, ST. S means standard and TN target. And they are presented in different probabilities in random order. It's not necessary that after 2S, T will come, but only the irregular and rare event, only the irregular and rare event, oddball event imposes the P300 peak into EEG about 300 millisecond for the stimulus onset. So only which is odd, that will only create, and others will not create much impact. The distractor, oh sorry, three terminal, three stimulus paradigm is modified. What is three stimulus? It is nothing but a modified oddball task that includes non-target distractor. So there is third one which is called as non-target distractor, infrequent non-target. Remember, this is also not a desirable target and not very frequent like S. All other S are frequent and regular, but this is also not our target, but infrequent stimuli in addition to target and standard stimuli. So what will happen, since it is a sudden, stimulus, therefore the distractor also produce some, response called as P3A. Look at here. It is similar to actually P3, similar to P300, isn't it? Which is very large over the frontal and central area, not the parietal area. Remember, the distractor, which is not actually the target, which will produce impression from the frontal and central area. Similarly, there is one more target, that is P3B, which is maximum over the parietal electrode lobe, which is maximum over the parietal electrode sites. So through P3, though P3A and P3B are subcomponents, I'm not saying they are not part of P300. They are actually around P300. Look at there. So P3A is dominant. Look at P3A is dominant in the frontal and central lobe with the small duration. The duration is very less because we also want, remember, the latency, the time gap to be longer. So its sustenance is longer. So P3A is of a small duration, latency is small, and the P3B is of little longer. So that is the introduction to your paradigm. This is very simple. In the beginning, you might be having some confusion. What is this? But when we go to the coming slides about other practical examples of paradigm, it will be very clear. So as you can see, there is one more picture which is coming. Look at, there is a stimulator, which is nothing but a board where a number of letters are written. So you may ask the subject or a person to do some mental task, on these on the basis of these letters. So doing the mental task or watching certain character, watching certain combination of characters, some reaction will be recorded at 300. This interpretation is actually reversely, highlighted. It doesn't mean this is negative. It is still P300, but see the arrow. The plot is just indicating that response is created at this parietal lobe. It doesn't mean it's negative. It is a positive one, value only. And then, the remaining process. We need not repeat the remaining process. We have already, discussed about the amplifier, ADC, signal processing. Then it goes to computing device where you use a number of AI ML method. And then that output may further be connected to the stimulator. You may further want to, do or perform certain task with the basis on the basis of this stimulator output. So you can give this as a feedback. So original response is coming from here. And how do we get the response? The first process is the stimulator that has generated certain stimulation signal, goes to brain generates ERP. After 300 millisecond, it is processed, and then we can use AIML to classify, and accordingly we can generate certain commands for certain operation. So what is P300? The main objective is to detect brain activities in EEG and communicate that activity to a computer or electronic device. That can be an electronic device, that can be a computer. We can communicate to that. So BCI is it allows to user to voluntarily send messages or control commands bypassing the brain's natural output pathways. I think you have to understand the difference. It is like unlike other BCI, where direct neural central nervous system direct neural interface was generating the command. Here the case is little different. It allows a user to voluntarily send. Remember, if you want with the help of a user to generate some voluntary message, and accordingly you want to generate commands or something by passing the brain's natural output pathways, this is possible in P300. So it's a safe and non-invasive system. Of course, we don't go for ECOG and that is a that field potential. We don't go for invasive method that requires user to wear a small hat cap carrying a set of electrode probes. So unlike like other EEG, we just the user is required, a subject is required to wear a cap, and that carries a set of electrode probes to detect the brain, that is ERP, event related potential. So how do we detect? We detect the detection, the subject to properly recognize the stimulus. The subject will be instructed or advised to recognize the stimulus that is generated by the stimulator that may be related to certain event to generate the strong and perceivable P300 event related potential. That potential that is very strong and perceivable. So as I mentioned that it may generate a number of times, and the accumulation of the signal actually comes as P300. So observable P300 is important for information transfer. If it is very weak generated stimulus and the response is very weak, then it cannot be transferred. So for appropriate information transfer, it must be noticeable, and which is not possible if the stimulation is presented too fast or targets appear too frequently. Let me explain this. If the stimulation which you are generating on a board and that a person is watching is presented very fast, quickly, then it won't generate that amplitude noticeably. Similarly, if targets which you are asking the subject to watch, they are coming regularly, very, very frequently, quickly, then the sudden impact or surprising event impact won't be created in the subject, and you may not get noticeable P300 amplitude. So there are some precautions which are very important when you work with P300. So BCI paradigm, what we were talking about, that helps to discriminate stimuli and be adjustable to users' adaptability to signal detection by controlling the stimulus presentation at slower rate. Therefore, we want the stimulation to be presented at very slower rate, slowly, brighter intensity. If you are generating certain letters or pictures, it must have brighter intensity or with increasing perceptibility. It must be perceptible by the person. The target to target interval from one target to other target interval, that also plays an important role in evoking the larger 300 ERP. So if the gap between one target and next target is very less, it means so many targets are coming very frequently, then the impact is not good. And therefore target to target interval plays an important role so that we get the larger P300 ERP. The paradigm, what we are saying paradigm again and again, remember some stimulator in a particular manner using certain mechanism or scheme we are using to create stimulation that is called as paradigm. It presents the stimulation at a constant rate, targets with low probability results in longer TTL. I have already explained you TTL. It it's not TTL, probably it is TTI, that is target to target interval, which is also a useful means to obtain perceivable P300 amplitude. This is to be read as a TTI. It is not TTL. So to useful means to obtain perceivable P300 amplitude. For a stronger P300, BCI is needed to maintain a minimum probability or maximum TTI. Probability of the occurrence must be not very high. The frequency should be less, so probability is minimum, and the TTI needs to be maximum. Such an action means the target which is coming is of longer duration and not frequent. Uh, the target stimulation reduces the system speed. And P300 amplitude can be increased by incorporating high temporal uncertainty. In this case, subjects are completely unaware of exact time. So when there is a complete temporal uncertainty that what time, what is going to come, in front of a person on the monitor or a display, that uncertainty will be there. So if more is the uncertainty, higher is the uncertainty, what will happen? Better will be the stimulation, because the subjects are unaware, they are not knowing about the correct time or a correct rate by which the target is coming. So the stimulation occurs. Other factors are also, there are other factors which are considered for P300 detection, like attention blink occurs in case of interval between two different targets that become less than 500 millisecond. The blink, which is called as attention blink, repetition blindness. Suddenly, repetition will be there. So it is a kind of blindness that leaves the second target unnoticed. So many targets are coming repeatedly. So maybe the next target may be unnoticed. If a two identical targets also flash at intervals between 100 and 500 milliseconds. Habituation making fainted 300 amplitude due to repeated presentation of same stimulus. So when you are, this is called as habituation. So habituation is a factor in which we are presenting same stimulus again and again. That also, is a factor that disturbs and that actually affects adversely the generation of ERP potential. And of course, these are technical factors, but there are some human factors such as motivation. The person who is trying to read something is trying to record something, trying to do something, must be, motivated. And the fatigue is a factor. If a person is tired, feeling fatigue, users comfortability has to be there to work on the BCI system. That all these factors affect the performance and accuracy of P300 BCI, and therefore considered in the design of paradigm. So when you consider a design, all these factors, technical factors, non-technical factors are considered while designing the P300 BCI. Now, till now, so far you might be wondering that what is this? What do you mean by, what is the use of this P300 BCI? You can understand, say a person is suffering with a severe disability and person wants to control home appliances, like a person who is paralysis patient or having serious brain disorder or disability, and can't even walk properly, can't even talk properly. Then the person can control the home appliances like refrigerator, fans, TV, the lights, etc., etc., present in the home. That is the major, benefit of this P300, by through which the person can have understanding of, so what can be done. Some paradigm can be developed for a person, and with the help of that paradigm, the person will understand, oh, this pattern is generated, so the pattern will create a reaction in the brain of a person, and that signal which is generated by the person will be able to switch off the light or switch on the light, switch off the television or switch on the television. So what is important is a paradigm. In the P300, most important thing is paradigm. Paradigm is actually responsible. What do we want to generate the final command that will help the person who is having certain disability. So I just wanted to tell you so that you don't lose the interest. Oh, what is this P300 BCI? So then next task is a very simple task like signal processing. You look at this interesting picture where only on one row there are some letters which are displayed that creates a stimulus, goes to brain. EEG data is acquired, goes to pre-processing. We extract the features. Features are used for sent to the classifier, and then it goes back. And then P300, it measures EEG from human scalp and processes them in real time to detect P300 and reflect the subjects. Remember, what is our main idea? What is our main objective? Our objective is to read the person's intent. What does person want to do? What does person want to do? Person wants to switch off the TV. We want to generate some signal. So accordingly, signal will be generated and will be used to either switch off or switch on the TV. So P300 evoked potential is elicited as a positive EEG peaks in reaction to infrequent or irregular appearance of the stimulus. Remember the property: infrequent, irregular. Infrequent frequency, the probability is very less. Irregular, the duration is long. Remember, the signal processing, I think, is not needed to again repeat. We have discussed about signal processing, in detail in our previous lectures. We know that there is a complexity in the brain. Complex signal comes in the form of EEG, and therefore it requires clear-cut distinctive cognitive functionality to interpret, and therefore signal processing is needed. And also we use the optimization method, and where we can optimize the accuracy of detection, and we can also enhance the system speed that depends on suitable signal processing scheme. Pre-processing, feature extraction, then detection and classification. These are the major stages of signal processing involved in P3 BCI, P300 BCI. So I think this is a very similar diagram where there are, this is the example where look at here that these are some sounds which are generated. And these sounds are being fed to the earphone. Look at the diagram carefully. So wireless EEG transmission to the computer. I have already told you there are wireless, the recorders or electrodes available with the help of Bluetooth or wireless technology. You can capture this and you can process the data. And what are the possible applications like wheelchair navigation? The person who is having disability wants to reach to little closer to television, wants to go to kitchen to take water, wants to go to, wants to go from one room to other room, one place to other place in a room in the home. So wheelchair navigation can help the person having physical or mental disability. Website navigation, where the person having disability can surf the website, can use the internet, and can have some entertainment or whatever programs or whatever surfing the subject is interested to do. And the home automation, complete automation of home, can also be designed with the help of P300 markers. So you see here that is directly connected to the visual stimulus controller. So the signal which is generated can also be fed back here, and the analysis can also change the stimulus further. So pre-processing, it leaves the significant intact. What do we do? Why do we use pre-processing? Again, we do not need to repeat. The meaningful information is not discarded. Whatever is which is not meaningful and unwanted, that is discarded, and the data is made appropriate. Classifier, it performance depends on an efficient data processing stage, and signal processing ensures. Why do we actually use signal processing? Another reason is so that a better signal quality can be ensured, having good signal to noise ratio. Background noise that can degrade the pattern. which is generated can be removed, can be attenuated, so that we can get the good P300 response. So P300 detection and classification become easier and simpler when we have a signal of higher SNR, and that is made possible by using appropriate signal processing. So signal processing and its discussion has been already made in very detail in our previous lectures. So EEG data is typically generally sampled at 256 Hertz. That satisfies the Nyquist sampling theorem. We know what is Nyquist sampling theorem. We have discussed about meeting this requirement as this rate is larger than, we know that it is larger than twice of the maximum frequency generated by the stimulus, yet low enough to avoid irrelevant data. Still the frequency is not very high. So to have higher SNR, we generally use a band pass filtering so that DC bias and high frequency noise can be removed. AC current generally is 50 to 60 Hertz. So therefore a notch filter either at these frequencies is used to remove power line effect on EEG signal. Power line interference is a common interference on the EEG. In order to remove that, we can use a notch filter. Certain types of artifact occur at known frequency and cognitive activity that limits in this particular range the operation of P300. So there are methods that are required to extract the features, and then features can be classified using suitable classifiers. Before classification test and actual use, we want to use P300 to to serve certain intention of the user. The classifier is trained and supervised using a algorithm, and feature vectors are labeled as target, non-target. Remember, therefore, if you see the output which is coming, stimulus is sent, and then response is coming, and it is being processed and again connected to the stimulator. Why? Because that classifier is trained and supervised using a classification algorithm so that the feature vectors can be labeled as target and non-target, because target and non-target discrimination is must for a person who is watching and wants to control certain thing with the help of that one. So trained classifier that helps to discriminate the brain response best resembling to target stimulus from non-target. So target to non-target discrimination is an important task. For example, there is a P300 speller. The classifier detects the letter with maximum probability. The letter which is having more probability is detected by P300 speller, and that we'll talk later in coming slides. So there are, like, just to give one example, if you remember one day, I was telling you wavelet coefficients. So we have to take wavelet transform and we can take wavelet coefficients as the features. So there are many features: mean value, power spectral density. So these are some, from the wavelet family like dB wavelet, Mottlet, spline, bioorthogonal, Gaussian, Mexican, Haar wavelet, right? Coflet wavelet. These are different families of wavelets which are used, and we determine the coefficients, and these are very powerful, the statistics or the metrics as the features. So the different methods are used like DWT or a principal component analysis. PCI is a very popular method, and the features which are given input to the classifiers for identification and classification may be of any type, like linear discriminant analysis, stepwise linear discriminant analysis, and so on. Like stepwise linear discriminant analysis, it is used to classify ERP using indivisible averages for rows and columns of 6 into 6 row column paradigm. So there is a monitor where you are displaying some letters where 6 rows and 6 columns are there. So that is a very perfect, fit for calculating indivisible averages using stepwise linear discriminant analysis method. We can also use classification methods based on AI/ML techniques, such as support vector machine and so on. You know how does a classifier work? It helps to classify the different feature sets or feature vectors into different categories. So you know that one feature vector is corresponding to target, other feature vector is corresponding to non-target. So that feature vector which is corresponding to target. So with the help of those features, then you can control the different commands, different devices. You can generate suitable commands, and just by pressing a button or responding to that stimulus and pressing a button, the person can control and person can run and switch on and switch off a number of appliances in home. So SVM support vector machine utilizes the small data size to give high throughput at high transfer rate. So therefore, this is also considered as a very important classifier, because it can still work on a small data set, providing higher throughput. LDA, even linear discriminant analysis, outperforms SVM for P300 detection if the input data is comparatively larger. So for smaller sized data, we go for SVM, because SVM generally works on smaller data with the high throughput, but the large amount of data is there, then we go for LDA that outperforms the SVM. Otherwise, the convergence will not happen in SVM when we apply SVM for large amount of data. So convergence is very important. What do we call and what is convergence in case of a classifier? Convergence is nothing but where further classification is not possible. Like there are other methods. These are also used as a popular classifiers for P300, Bayesian LDA, linear discriminant analysis, Pearson's correlation method, PCM, linear support vector machine, LSVM, Gaussian support vector machine like GSVM, and so on. These are other methods which can be seen. You can see the literature where P300 uses these methods as the classifiers. So what is the advantage of P300? We have uh, we have seen the overview, the introduction, what is P300, what do we mean by paradigm, and what is the role of paradigm, how does it work, how does it read the stimulus and react to the response, and then how does it control. So what is the advantage? It can be controlled with high accuracy, and classifier offers fast response used in gaming applications where classifier accuracy is not very critical. Means one can choose different gaming applications and control severely paralyzed patients. I think this is the most exciting and interesting application or advantage of P300, where severely paralyzed person can be assisted, and the severely paralyzed person or a patient can have a control over different appliances in the home. Unlike other BCI, like motor imagery BCI we have talked about in the beginning, no special training is needed to operate this BCI, because the output and the interpretation is actually user's intent. What does user want? User wants to run the fan, and accordingly that impression will create a feature set, and feature set will create the difference between target and non-target, and accordingly the execution will take place. So it is unlike motor imagery where you have to read the brain and understanding huge amount of EEG signals, you have to do some motoric tasks. So it is not like that. So this is the advantage. Advancement in a P300 in 1988, Farwell et al. It was actually presented first time in 1988 about P300, and it was presented as a seminal study to demonstrate a potential of P300 based communication with P300 ERP based speller. One P300 ERP based speller was used, and it was demonstrated how does P300 communication could be established. Many P300 based PCI systems are following after that as a benchmark of P300 ERP application. In addition to improved information transfer rate, there is a significant improvement in information transfer rate. Remember, in the BCI, data transfer rate, information transfer rate is a crucial factor, remember, when you design a BCI. So therefore, improved information transfer rate, current P300 BCI explores new electrode montage, how the improvements can be made. There are various, research and advances taking place in order to improve the performance of P300 in all upcoming versions. So how can we do the new electrode montage? I have already explained montage means arrangement of electrodes. Can we take different kinds of paradigms? We have yet to discuss paradigm in detail and applications to increase the performance of BCI that can actually assist disabled users in home setting or in the home environment. For example, effect of contrast or a color, proper value of contrast and color, modified stimulus presentation. Can we modify the stimulus? Can we change the contrast and color of the stimulus? Enhanced users attention and new paradigms for eliciting P300 have been introduced as new ways to improve ERPs and its classifications. The aim is to improve the performance of ERP so that users' intents can be very properly interpreted, and for the users' intents, we can serve the needs of users. BCIs are still slower. The speed is always an important issue in BCI than the normal electronic input devices. Whatever the input electronic devices are there, they're having much higher speed than the BCI, such as the mouse, game controller. They are having more speed as compared to BCI. The response time is slow, isn't it? So we have to keep all these things in mind while going for advancement in the BCI. So what are the applications? Typical application is a P300 speller. We will discuss about this. Visual paradigm. Visual paradigm is made up of matrix. Remember, these paradigms are the applications we are saying. Why? The paradigms are actually paradigms are actually used by the persons for their intention, for using or for having certain controls based on their intents, based on their needs. So therefore, these are covered under applications. So visual paradigm is made up of matrix consisting of some letters of the alphabet, and depending on requirement, a speller can be optimized for quick selection or accuracy of spelled letters. So there may be different types of matrices. There may be different types of spellers. Similarly, other P300 BCI investigations are there is enough progress in this area to develop other attractive applications such as painting artwork. I have been I can tell you in MIT they are actually working on a lot of work is going on robot that can be controlled by BCI, where they have demonstrated this particular application painting artwork. And what is interesting is you can even correct the robot which is trying to do something incorrectly. Means the robot is what I can say, doing some errors. So that commuting some errors, so that error can be corrected by the BCI command. So that work I have seen done by a few professors at MIT, where the painting work was tested as a, for demonstrating that error correction in the robotic application. Controlling a smart home, I have already talked about. Designing games, stroke rehabilitation, lie detection. Very popular application of P300 is lie detection. You might have heard about lie detectors in the criminal investigation. When a, of when a person who is a criminal, who has done some crimes, and we actually want to assess whether the person is telling truth or not. So in order to assess that and furnishing internet task, these are the applications like a smart home. The applications which are included there one by one, I'm quickly just explaining, and then we'll go for paradigms. Like smart home, you can see that participant is having some reaction, and then EEG signal, and then data analysis training phase, and that goes as a feedback stimulus, and actually that person is watching something, if you remember, that is very important. And based on that watching something, the person can control all these appliances which are there in the home, and therefore this is called a smart home, intelligent home. It can be controlled by BCI with the help of AI ML and the classified response from the received from the brain. So different electronic devices can be controlled. Execute a group of controlling commands such as moving a cart or a wheelchair. Wheelchair can be moved, receiving or making phone calls, The person with paralysis or stroke can make a call, can operate television, can switch off or switch on the light, can play song in multimedia player, can switch off the player, can change the song and so on, or controlling the doors and windows in the home. These are some, but there are many other areas in which smart home applications are greatly supported by the P300 BCI. Like internet use, I was telling you internet use. So if a person having the disability wants to surf the website, wants to work on internet, it can be used. P300 can be used to select internet keys to provide assistance to amyotrophic lateral sclerosis. This is a disease, a person who is suffering from patients browsing the websites will have difficulty to use. So that person can be assisted by the P300. Subjects can surf through internet pages and select the desired links to browse the internet or read the news or can watch some entertainment program. Like painting example I was telling you, it can be used and brain painting can be achieved and that can offer a medium of entertainment for the patients. So they can do some entertainment work. They can make the painting work as their hobby and can actually create some good paintings. Otherwise, generally, the people who are suffering with mental disabilities and disorders, they need a lot of motivation and encouragement. Otherwise, many of them, do have some stress, and that stress further causes, in fact, further escalates their mental disorder. So in order to make them busy, in order to make them engaged, this kind of application is very important where they can do some painting or they can do some they can perform certain tasks. So here also visual stimulus is going, it is being generated with the help of some device and EEG amplifier. Visual stimulus is being given to the person, and remember there is always an interconnection between the two. The person is expressing his intent that he wants to do something, remember, and accordingly stimulation is generated, isn't it? So it's very interesting, stimulus is generated and then finally it is going there and properly detected and analyzed will actually generate certain command, and that command will then help the person to do painting task and it will help his arms to move or something like this. Gaming is another area where interesting application of P300 is there, where simple games that do not require strong time constraints, such as playing chess and all that. Simple games can be played by a person. In mind game, the user's move depends on brain response. P300 ERP is stronger. The game character can move longer distance. In bacteria hunt, I mean, these are, you might have heard about these games, mind game, bacteria hunt. Users can change the color of the image or enlarge or rotate it. And these are some more brain invaders. The users needs to select appropriate target arms to destroy the aliens, which make the game interesting to the video gamers. And rehabilitation is the, a very useful area in the area of healthcare, where the paradigm P300 BCI paradigm, it is used to provide communication channel to the participants who are diagnosed with the post-stroke aphasia. P300 BCI not only allows to activate their language circuits, but also made their post-stroke recovery faster. So this is actually, a great contribution, great, tool for the persons who are having, the stroke or brain stroke. So primary auditory cortex and the secondary auditory cortex goes, and some area which is called as Broca area, that auditory response comes, it goes to motor cortex, brainstem activation, and speech production. So what is the meaning? That that signal which is generated can be given as a feedback to these layers, and finally it can go to motor cortex and brainstem activation. And this brainstem activation can actually help in a correct generation or speech production where the person is unable to produce the speech. So this kind of rehabilitation is possible in using a P300. Lie detector, I was telling you, different brain regions work together and generate activities to process And you might now, you can now very easily understand the principle of lie detector. When you are normal, when you are abnormal, when you think normal, when you think abnormal, when you tell truth, when you tell lies, obviously your response would be different. Your EEG response would be different. So whenever there is abnormality, that person will be asked again and again that what was your response to, where did you go that day, where were you that particular time. So in the criminal investigation, this helps a lot. The concealed, the person who is hiding actually some information can be easily identified through concealed information test called as CIT. The study is mostly used in oddball paradigm. I was telling you, they will not ask uh, all the simple questions or what I can standard questions. They will be asking standard questions, but suddenly they will be also asking some oddball paradigm. They will be asking some surprising question. The person's response will be very, very different. So three types of stimuli: target, probe, and irrelevant. Whether the paradigm was target, whether the paradigm was a probe for investigation, or whether the paradigm is actually irrelevant. Accordingly, the analysis called as concealed information test, CIT, is performed in the lie detection process for criminal investigation. Like a typical P300 based system, targets are presented rarely through, they are usually made of irrelevant items. So the target which the investigation officer wants to assess from the person will be presented very rarely, and to ensure participants cooperation in discriminating the target items from the others. So many things will be shown in addition to the target. Whenever target comes, his response will be observed. The irrelevant items are presented frequently, but they are neither related to criminal act nor related to the experimental task. So suddenly, it may not be he's a criminal, the investigators investigating officer is having doubt that this person has done some crime. So that similar crime might not be. There may be some non-criminal acts also which are not related with these crimes for which he has been booked, or some other experimental task might not be there. Something which is irrelevant, something which is irrelevant is presented frequently. Then wants to us. Subjects will have different responses to stimuli according to their crime relevant status. So for all the stimuli, the subject will be responding differently. And this analysis is done, and based on the analysis, the investigation helps in understanding whether the person is telling truth or lies. Like this is one example, like a black screen, for resting time 0.5 second, then the stimulus begins and some picture is shown, and after 1.1 millisecond stimulus again there, and after certain amount of time again something will be shown. So this is something which is displayed, or some character will be displayed, and wherever he finds some irrelevant, the response will be recorded. To ensure reliable difference between liars and truth teller, how to identify, how to differentiate between, suppose a person who is telling truth, uh, he is asked to go through the lie detection test. So how to differentiate? Remember, it is not 100% authenticated system. You all know that, but it helps the investigation. What does it do actually? It helps the investigation to get some facts. The person might, disclose some information that about his availability, about his presence, about his acts during certain time, during certain week or days or something like that. So that actually gives some more information to the investigation. It does not always guarantee that the person will say that no, I have done this crime, this is how I did my crime. Might be one of the response, but all associated actions will also be presented, will also be responded by the, might also be responded by the person. So it is very important to differentiate between liars and truth teller. It is important to engage multiple channels that result in ERP features from different brain areas. So one study that investigates the functional connectivity of a brain network under deception condition. If the person is trying to deceive, will be identified. The correlation was found between different EEG signal from multiple channels to understand interactions between brain regions and functional connectivity. So wherever there is some similarity, disassociation indicated, that time, we'll find out that something is wrong where the subject is telling lies. So the results indicate the incorporation of additional features that help separating innocent group from the liars with 90% of accuracy. Remember, this is what I was telling you. It is not necessary that we will be able to finally detect that this person is telling lies or this person is admitting his crime. It's not possible always. But what is important is additional features, additional information will be given by the person that will help us to separate other people, because in the criminal investigation, when some crime has happened, so the investigating team may ask more number of people to come and join the investigation. So in that case, those who are not liars can be separated from a very minimum group, small group, where there is a, the liar is likely to be there from that group. So that is possible. So P300 speller, I was talking about P300 speller. What is this P300 speller? This is used as a communication tool. Remember, I am talking about paradigm again and again, again and again. I'm also talking about stimulator again and again. So this P300 speller is a stimulator, or you can say communication tool, used by the people who are suffering from various neuromuscular disorders, like I'm unable to use my fingers to do some tasks, to run the keyboards, to operate the keyboard, such as brainstem stroke, brain or spinal cord injury, cerebral palsy, muscular dystrophies, multiple sclerosis, and other impaired patients who are unable to use the normal neuronal pathway or normal neuronal activity. So for all these people who are having certain kind of neuromuscular disorders, this BCI speller called as P300 speller is used as a communication tool. So the research in BCI is always there to improve the accuracy. Research is always ongoing to make better and better, so that accuracy and speed of speller that can result in numerous P300 stimulus presentation paradigm, so that the speller can generate the correct stimuli that can actually help the person to what I can say, to fulfill his needs as per his intention. Whatever his thought, whatever he wants to do, whatever he or she wants to do, can be performed by generating certain features, and classified features can generate certain commands. So therefore, accuracy is very important. Speed of BCI, how fast the response is coming, that is very important in order to ascertain that P300 stimuli is effective and actually helping the people who are having certain kind of neuromuscular disorder. So let us talk about paradigm now. This is another interesting paradigm called as a row column paradigm. You can understand why it is called as row column. There are rows, there are columns. If you see this matrix, you have 1, 2, 3, 4, 5, 6, 6, rows are there and 6 columns are there, where you can see there are some alphabets and there are some numbers as well. A to in fact Z, all letters are there, 0 to 9. So 26 plus 10, 36. Therefore, this is the interesting combination of taking 6 cross 6, because it covers all your alphabets and all the numbers of your decimal system. So this paradigm is very popularly known as row column, rather abbreviated as RC paradigm. RC paradigm. Farwell and Donchin, this is the these were the people who introduced this matrix speller paradigm. Farwell and Donchin paradigm. It was the first BCI row column speller using an alphabetical square matrix interface to produce P300 in EEG. So when a person watches a particular letter, particular character, alphabet and number, that produces certain EEG in the P300 system. Rows and columns are 6 by 6 with alphanumeric characters, alphabetical as well as numbers. The characters are flashed randomly following either a row or. Remember, what is important is to generate certain stimuli, to create certain irrelevant and infrequent response, the response which is not frequent, and that is will be done either a row or a column, and the subject is asked to mentally count the number of times that the attended character is placed. You can say that the person that count how many times am is appearing, capital M is appearing, and you are not generating M again and again. The frequency is not regular. Sometimes you're generating some other alphabet, sometimes you're generating number. And say you asked the person that just watch this for 3 seconds or 9 seconds or 10 seconds. And in 10 seconds, tell me how many times letter P is appearing. So that will actually create some impression in the stimulation in the mind. So during the brain signal measurement in the parietal area, as I have told you, P300 is a potential where parietal lobe is affected. So parietal area, it appears in the EEG as a evoked response. So due to the nature of stimulation mechanism, I'm sorry, to increase the accuracy of detection, P300 requires multiple trials to reach an acceptable accuracy. It has to be done again and again so that it can create the actual impression. Non-target rows always also generate P300 for a small duration, but the amplitude is too faint to detect. So it will not be accepted as a target. The computational device can determine the target row and column after averaging several responses. So you can get so many times the responses and you can calculate the average response of that. Due to averaging task, it may take again the longer time to detect a particular character. So this the previous one was the row column paradigm where you may generate certain row and you may generate certain column and you may ask that how many times a particular letter is coming. Single character paradigm, popularly known as SC paradigm, you can understand only one letter, one character is being displayed. So the process is similar. This is one of the simplest speller design in which it flashes one character at a time with very small duration, very short duration it will be displayed. The paradigm also uses 6 by 6 alphanumeric paradigm. It was reported that RC paradigm takes less time than SC paradigm to flash all the characters to this one. You can understand if you want at least every character to flash once, SC paradigm will take more time because here you are always flashing only one character at a time. So if a number of flashes is constant, the SC speller produces stronger P300 ERP than RC speller. So if the number of displays is constant, the SC will produce stronger because the character which is being displayed is a single character. So the person will be able to actually count or remember that region based paradigm. Look at the patterns. These are different patterns where number of rows and columns might not be the same. You see 1, 2, 3, 4, 5, 6, 7, 8. Here also it's looking like your keyboard of your computer. So it's different. It's not similar to RC and SC. So to distribute the characters in larger area than the RC paradigm, the choice of an object is split in dual selection, which decreases the near target effect and humor error and adjacency problem significantly. Correct. So what do we do? That it is split in a larger area, that is region based. And the space of visual paradigm is divided into 7 different groups. Visual paradigm. There are 7 different groups actually, where the numbers are there, the alphabets are there. There are 7 groups. Desired characters are split into 7 groups, and each group is placed into a single region. And for any given spelling task, user has a few seconds to focus on characters before the action of each level. This action produces ERP for the first level target. The regions are flashed in randomly order by repeatedly changing its color between the black and white. The color will be changing. The choice of color needs to be justified with the purpose of the application. For simple spelling tasks, common black-white transition usually outcomes better contrast. Black and white and black, So the frequent transition will give the better contrast. As a paralyzed people need to spell the desired word with minimum movement, the arrangement of letters can be adjusted accordingly to optimize the performance. The next one is checkboard paradigm, CB paradigm. These are the characters which are used in the checkboard paradigm. Like in checkboard paradigm, RC was modified to eliminate the error caused by adjacency problem as a human error in P300. So the error resulting from non-target items receiving apparent target responses is reduced, because error will always come when you are having confusion between target and non-target. 72 characters in standard 9 by 8. Probably this is 9 by 8. 1, 2, 3, 4, 5, 6, 7, 8 this side. So 8 columns, and rows are 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 rows and 8 columns are distributed in two virtual levels, where each level is a virtual checkerboard, a node modification to row column paradigm implemented in a checkerboard paradigm called as CB paradigm. So this is, the paradigm which is used for checkerboard, where you will display or flash any particular pattern or a character a number of times, and then you will be asking for certain tasks. This reduces the chances of same character displaying twice in succession, therefore increasing the time between successive displays or flashes of a target character, because frequency is very important. So where is the future of P300? Future use. Many future directions are there to improve information throughput, which also equally true for many other types of BCI system. To uncover the applications of other modalities, can we use other modalities underlying physiological mechanism? The brain response in each particular application need to be carefully investigated. So these are the areas where research is ongoing in the area of P300. For example, study to unfold more insight of cognitive process. The study to uncover more insight of cognitive abilities and processes that indicates that the neurofeedback can be applied to augment the cognitive diagnosis. So the neurofeedback, can it be generated, be given back to the person to improve the cognitive ability or cognitive, disability, to to get better ability. In order to increase BCI accuracy, error correction schemes can be incorporated into the BCI system so that there is no error. Future BCIs need to be faster. I have told you accuracy and speed are very important. So the coming BCIs needs to be very fast responding, and also to be inexpensive. 1020 is the internationally used system for standard positioning scheme based on iterative subdivisions of arcs and skull, like Nasan, Indian, left, right, all are known, and then accordingly you write the different terms. And why it is 1020, you can see this relation. This is 10, this is 20, 20, 20, 20, and this is 10. So this is how, and in some time here also you see 10, here it is 10, and others are 20. So this gap is 10. So in most of the cases, difference is either 10%. 10% of what? 10% of this total. 10% of this total will be divided into this one. Like 1, 2, 3, 4. You see here. This total, say, what we can say, it's not, yeah, half of the perimeter, isn't it? You see, if it is 100%, so between these two, 20%, between these two, 20% and 20, and then this is 10%. Similarly, internally also it has been divided like this. So this is why we call it as a, 10-20 in the international system. So original 1020 system includes only 19 electrodes, and then 70 electrodes were included later. The extension also renamed 4 electrodes called as T3, T5, T4, T6 for T7, T5. So these were the new names in place of these respectively later version. Sometime one of the electrodes mounted in this position is used as a reference channel. If you remember our discussion on montages and electrodes, we use it for the reference voltage. Talking about impedance, he was also mentioning about the impedance. Impedance between scalp and electrodes measured in kilo ohms is a main factor of recording a signal quality. There is an impedance between scalp and electrode that is measured in kilo ohms. You have seen in the example, it was some 130 kilo ohms. So he put the gel and then it was reduced. High impedance indicates poor conductivity between the electrodes and the underneath skin. So rubbing the skin, if you remember, he was putting a thin element and he was trying to rub with the wooden stick, exactly what he was doing. So rubbing the skin using a wooden stick can break the dry tissue on the surface and increase the conductivity. So the purpose is to increase to reduce the impedance. For wet electrodes, sufficient gel can moist the skin throughout the times, which lowers the impedance. Like see the impedance before rubbing the skin and applying more gel. The person was trying to just rub the skin and before rubbing the skin and just trying to put gel. But even though it was not good because that area was not allowing. So when it was rubbed with the wooden stick, it allowed that gel to go inside. So impedance after rubbing the skin and applying more gel. So you look at both the cases. In the first one, the signal is very much distorted, but in the second one, there is a lot of clarity is there, which is coming from source. So this is the application of the wooden, thin material by which you are rubbing the skin and then you are putting the gel. And the why this is coming again. So brain signal quality can also be inferred by surrounded electronics. Electronics are there, signal processing circuits are there that can also interfere, called as artifact. So we can use a number of cables, we can protect them. Nearby walls can induce the noise in the raw signal. So we can use some suitable filter to improve the signal quality by removing them. So like this, you can just remove the noise from here and you can make it better and reducing the interference. Like electrical power line interference, which is there in between 50 to 60 hertz, that also creates sometime power line interference. Power line is defined differently in different countries, like 50 hertz are used in Europe, Asia, Africa, and some parts of South America, and 60 hertz are used in North America and some parts of South America. Mains voltages is 110 and 230 volt. Talking about the amplitude, therefore, it exceeds it is much more than the EEG voltage, which is in microvolt by a factor of several dB. And therefore, amplifiers have to are provided to amplify this signal and we get the better strength of signal. Amplifier and notch filters are designed to suppress the certain amount of mains interference. This notch filter was also highlighted in the video which we have seen. When there is a mains interference still is visible, suppose still interference is there, then we can activate the notch filter and can reduce the interference. Now talking about the blinks, eye blink artifacts are generated by the fast movement of eyelid among the cornea, and it happens during an eye blink. You have seen in that example when eye blink was there, the distortion was taking place in the signal. By friction between lid and cornea, this movement results in a charge separation. This is talking about the phenomena. Why does it cause the movement and blink? With the dominantly dipolar charge distribution, the dipole moment pointing in up-down direction, and therefore our lids start blinking. So in the EEG, this recorded as a positive peak lasting a few tenths of second, mainly visible in the front polar region, but propagating to all the electrodes on the montage, becoming weaker and distant from the front. But still, that can be measurably seen. For blink artifacts, power content and the frequency components in the alpha band is negligible, so they produce no apparent effect on data analysis. At the same time, the amplitude is quite large, so that time domain analysis can be strongly influenced by the response. Like this is from the different areas and the different signals which are recorded, reducing the interference. So eye movement, that was just telling the impact of blink, and you could also see in the example. So eye movement artifacts are produced and generated by a frictive mechanism similar to underlying blink artifact involving retina and cornea. And the effect on front polar and front temporal electrodes can be symmetric, asymmetric. So there are different types of patterns that can, affect the original signal using artifact created by the eye. Like this is muscular artifact related to some muscular movement. You'll get different types of artifacts from the different channels, and that can also be corrected. So most common sources of EMG called as muscular artifact are the muscles that lift the eyebrows. You have some muscular movement with that you lift your eyebrows, and those which you close the jaw. You know that also causes the what we say is the artifact, and that needs to be addressed. So this is the end of this particular part of PowerPoint, where we have talked about the fundamentals, the theoretical background, the overview, the significance, the application of P300 BCI. And also we have tried to understood one practical example of BCI with how paradigms are used, how recordings are used, how paradigms actually help the persons to read the stimuli and then try to create certain impression, and that impression generates the feature vector. Feature set can be classified, and can that classification be used for generating a number of commands, or user can himself control certain operations with the help of those feature sets, which are further received by the stimulator, and that comes back to his brain again.